Imagine you're standing at the edge of a cliff. Now multiply that drop by 10, then 20, then 50 times over. You're now looking at the deepest parts of our ocean, where the pressure alone would crush a car like a tin can. But here's the thing. Life doesn't just survive down there, it thrives, and it looks nothing like anything you've ever seen on land. Down in the midnight zone, fish have evolved features so extreme, so bizarre, that if you saw one washed up on a beach, you'd swear it was from another planet. Bioluminescent lures dangling from their heads, teeth like surgical needles, eyes the size of dinner plates. Some fish are literally transparent, others have mouths so large they can swallow prey bigger than themselves. But these aren't mutations gone wrong, they're perfect solutions to the harshest environment on Earth. And today, we're going to explore how extreme pressure, complete darkness, and crushing scarcity have transformed ordinary fish into creatures that seem to defy the laws of biology itself. Before we talk about what lives down there, we need to understand what down there actually means. The ocean has layers, and as you descend, the conditions become increasingly hostile to life as we know it. The sunlit zone extends from the surface down to about 200 meters. This is where most of the ocean's life happens. You have whales, dolphins, sea turtles, creatures you'd recognize. Light penetrates here. Photosynthesis happens. It's relatively crowded. Below that is the twilight zone, reaching down to about 1,000 meters. This is where things start getting strange. Light is fading, becoming blue, then darker shades of blue. Some creatures in this zone can still see, but visibility is poor. The pressure here is intense, about 100 times stronger than at the surface, but life can still adapt to it with relative ease. But then you cross into the midnight zone. Below 1,000 meters, there's no natural light whatsoever. Not a single photon from the sun reaches these depths. The pressure is so extreme that it would flatten your lungs in seconds. The temperature hovers just above freezing. Food is so scarce that organisms have evolved to make the most of every calorie they encounter. Some fish might go months without eating a single meal, which would starve almost any creature at the surface. The deepest parts of the ocean, the abyssal zone, extend down to about 6,000 meters. At these depths, the pressure is roughly 600 times stronger than at sea level. If you took a human body to these depths without protection, it would compress into a fraction of its original size. Your bones would crush, your organs would collapse, and yet fish live here. Not just survive, they thrive. The deepest part of the ocean we know about is the Mariana Trench, which plunges to nearly 11,000 meters below the surface. Even there, life exists. We've documented fish living in trenches at depths where the pressure would seem to make any normal animal impossible. So, how do fish solve these problems? The answer lies in understanding that evolution doesn't care about what seems possible. It only cares about what works. And in the deep ocean, the most unimaginable adaptations are the ones that keep you alive. Let's talk about pressure first, because it's the foundation of everything else we're going to discuss. At sea level, we live under about 14.7 pounds of pressure per square inch. It doesn't feel like anything because we evolved in it. But dive down to just 10 meters underwater and you've doubled that pressure. Now imagine going down 2,000 meters. The pressure there is about 200 times what you experience right now. Your cells are being crushed from all directions simultaneously. The water itself is trying to compress you into oblivion. Fish in the deep ocean have solved this problem in a way that seems almost too simple. They don't fight it. They accept it. Most deep-sea fish have a body composition that's almost identical to seawater itself. They have very little bone structure. Many species are soft-bodied, gelatinous creatures. Some fish from extreme depths have almost zero swim bladders, those organs that allow surface fish to control their buoyancy. Without a swim bladder, they can't get crushed. There's nothing to compress. They're already at equilibrium with their environment. But there's more to it than that. The proteins and fats that make up a deep-sea fish's body are chemically different from those of surface fish. They're designed to function under extreme pressure. Think of it like this. A deep-sea fish's proteins are engineered versions of what we'd find in any fish, but with modifications that make them stable when they're being squeezed by forces you can barely imagine. This is where we start seeing the truly strange adaptations. Some fish have developed eyes so enormous that they take up nearly 30% of their total head volume. The giant squid, which lives in the deep ocean, has eyes the size of dinner plates, literally 27 centimeters in diameter. That's bigger than a human head. In surface waters, such enormous enormous eyes would be wasteful. Energy is limited. Why invest in huge eyes if you're only seeing things within a few meters? But in the deep ocean, where light is almost non-existent, bigger eyes capture more of whatever light is available. But here's where it gets really interesting. Some deep-sea fish have evolved tubular eyes. Instead of the round eye you see in most fish and humans, these creatures have eyes that are shaped like tubes. The lens sits at the front, and the retina lines the back like a deep cylinder. This design makes the eye extraordinarily good at seeing things straight ahead, but almost useless for seeing peripherally. It's the optical equivalent of a high-powered telescope. These fish are essentially looking through a snorkel at their world. The purpose of these extreme eyes only becomes clear when you understand what deep-sea fish are actually looking at. Many creatures in the midnight zone produce their own light. This is where the deep ocean gets truly alien. About 90% of deep-sea creatures generate their own light through bioluminescence, not for fun, but as a tool for hunting, communication, and survival. The female anglerfish is the most famous example. She dangles a bioluminescent lure filled with glowing bacteria in front of her enormous mouth. When prey approaches the light, attracted and defenseless, her jaws snap shut. She doesn't need to hunt often. When she catches something, she might digest it for weeks. But the anglerfish's strategy is just one approach. The hatchetfish uses bioluminescence for camouflage, lighting up its belly to match the faint glow filtering from above, becoming invisible to predators below. The lanternfish produces specific patterns of light that serve as identification signals, creating a silent language in complete darkness. Some fish produce red light that only they can see, a private communication channel invisible to predators. The chemistry behind this is elegant. Most creatures use luciferin and an enzyme called luciferase to produce light. Many fish farm bioluminescent bacteria in specialized organs, essentially cultivating living light factories inside their bodies. Different creatures produce different wavelengths. Since most deep-sea fish can only see blue light, the creatures that produce red light are speaking in a language only their allies can understand. Predators pass right by, unable to detect the signal. These aren't random glows. They're calculated, targeted, and deeply purposeful, and they're just the beginning of how extreme life becomes in the darkness. Let's move on to the most striking feature of many deep-sea fish: their mouths. These aren't cute. These are evolution perfected for one purpose: catching food in an impossibly scarce environment. The fang-toothed fish has teeth proportionally larger than any land predator. They're so large the jaw won't close. Two fangs protrude like tusks. These teeth are for precision. In the deep ocean, you can't afford to miss. If you strike and fail, you've wasted energy you might not have. The teeth do the work without requiring a powerful bite, but the real adaptation is the skull itself. Many deep-sea fish have skulls made almost entirely from cartilage rather than rigid bone. This allows mouths to open at nearly 180 degrees, angles impossible for any surface animal. The pelican eel can open its enormous mouth wide enough to consume prey nearly its own size, with teeth angled inward like a trap. But the black swallower is even more extreme. At just 25 centimeters long, it swallows fish 3 times its size. Its stomach is elastic enough to accommodate prey far larger than itself. The cost is severe. Digesting this meal takes weeks or months. During this period, the fish is essentially immobilized, vulnerable to any predator. It's a calculated gamble: catch something big, endure the vulnerability, survive the slow digestion. The gulper eel takes a different approach. Almost entirely mouth, it passively swims through prey swarms with its jaws hanging open, catching whatever enters. Now we've talked about creatures that glow. We've talked about creatures with enormous mouths. But what about fish that are essentially invisible? The barrel-eye fish has a head that's almost completely transparent. Behind it are tubular eyes that point straight up, scanning for prey silhouettes against the faint light above. And remarkably, these eyes can rotate forward to look directly ahead for precise targeting. Maintaining transparency requires extraordinary precision. Most animal tissues scatter light because they have different densities. Transparent fish solve this by minimizing these differences. They have very little pigmentation. Their blood contains minimal hemoglobin. Some position their dense eye lenses to the sides rather than in front, preventing them from blocking light traveling through the body. The glass squid takes this even further. It's almost entirely transparent, except for a thin layer around its digestive tract. After eating, the food is briefly visible as a dark shape in its gut. Once digested, the squid becomes transparent again. This strategy comes with a cost. These creatures catch almost no food accidentally. Every calorie has to be actively hunted. They've committed entirely to one trait: invisibility, and they're locked into that ecological niche. What we're looking at across all these adaptations is an arms race that's been running for millions of years. Predators evolve better ways to catch prey. Prey evolve better ways to hide or escape. Predators then evolve in response to those new defenses. In the deep ocean, this arms race has created creatures that seem almost alien. The viperfish combines multiple hunting strategies: teeth that protrude from its closed mouth, a large jaw, and a flexible body that allows it to coil and strike. But it's not the apex predator. Larger fish hunt it. Squid hunt in the darkness with their own specialized adaptations. The giant squid, growing over 12 meters long, is hunted by sperm whales that dive to 2,000 meters or deeper. What's fascinating is the hierarchy this creates. Creatures at the top of the food chain have the most specialized sensory organs. Creatures in the middle rely on defensive strategies, bioluminescence, camouflage, or transparency. At the bottom are billions of small crustaceans and fish that lack specialized adaptations, but compensate with numbers. Even the tiniest creatures show adaptation. Copepods, often just a few millimeters long, are among the most abundant animals on Earth. Many have evolved to migrate vertically through the water column, traveling hundreds of meters between depths seasonally, a movement so massive that scientists believe it's one of the largest animal movements on the planet by total mass. All these adaptations, the enormous eyes, bioluminescence, flexible mouths, point to one truth: deep-sea fish have fundamentally changed how their bodies work. A surface fish eats several times daily. A deep-sea fish might eat once every few months. This is achieved through multiple mechanisms. Deep-sea fish have lower metabolic rates overall. They're less active. Where surface fish constantly search for food, deep-sea fish conserve energy. They drift. They wait. Their muscles are structured differently too. Less white muscle tissue for speed, more red muscle tissue for slow, sustained contractions. This is muscle for floating and drifting, not chasing prey. Most remarkably, deep-sea fish have evolved thermal tolerance. Their proteins and enzymes function optimally at the near-freezing temperatures of the deep ocean. Where a surface fish's metabolism would slow to a crawl, a deep-sea fish's continues at a steady pace. The female anglerfish exemplifies this revolution. She hangs motionless in the darkness with her lure dangling. She doesn't actively hunt. Her entire metabolism is calibrated for sedentary existence. When she eats, she digests it for weeks at minimal energy expenditure. She's abandoned the active hunting lifestyle of most predators in favor of something fundamentally different: maximum patience. In an environment where prey is randomly scattered and incredibly scarce, this strategy is incredibly effective. But even among deep-sea creatures, some have pushed adaptation to its limits. The Dumbo squid lives below 4,000 meters, almost entirely gelatinous with soft, flexible fins. It scavenges organic debris falling from above rather than hunting. The barreleye has optimized itself so completely for looking upward in the twilight zone that it probably couldn't survive anywhere else. The spookfish has transparency so complete that its brain is visible, with eyes positioned at the sides for 360-degree vision. And then there's the sea pig, not a fish but a sea cucumber. It lives on the ocean floor at extreme depths with almost no muscle. It's essentially a living bag that crawls slowly along the bottom, feeding on organic debris. It might be the most energy-efficient large animal in the world. The deep ocean has transformed fish into creatures so adapted to their environment that many of them couldn't survive anywhere else. A barreleye brought to the surface would experience rapturous expansion. The pressure that holds its body together is gone, and its fragile form would be destroyed. An anglerfish brought to the surface would be crushed by gravity and the weight of its own tissues, deprived of the pressure that's held it together for its entire life. These creatures aren't monsters, they're not mistakes, they're elegant solutions to one of the most hostile environments on Earth. Every feature we find bizarre, the enormous eyes, the bioluminescent lures, the transparent bodies, evolved because it works. In the deep ocean, under pressure that would crush anything built for surface conditions, with food so scarce that meals might be months apart, in absolute darkness, where light is a tool that needs to be manufactured. In this environment, these adaptations aren't just successful, they're perfect. If you want to understand what life looks like when it's pushed to its limits, the deep ocean is the ultimate laboratory, and what it shows us is that evolution doesn't care about how strange its solutions look to our eyes. It only cares about whether they work. And down there, in the midnight zone where the pressure is crushing and the darkness is absolute, they work beautifully. If you enjoyed exploring these incredible creatures from the deep, I'd love for you to like this video and subscribe to the channel for more deep dives into the strange science of the natural world. Thank you for watching.